Namaskara. Let's understand of how we could merge two sorted linked lists into a single one in this video. There are multiple ways to do it, but the approach that we are looking here is to do this task without creating new nodes. So let's get started to understand the problem statement. So there are two lists given to us. So let me call them list 1 and list 2. Right? So individually, the two lists are sorted, and what is expected after the task is to combine them into a single merged list. So the original list 1 had 5 elements, list 2 had 5 elements, and after the merging, my final list, as you can see here, should have 10 nodes. And if you could see, all of them are sorted. So let's see of how we could get this task done. There are two assumptions that we will do in this process. Yeah. The first assumption is we have to start with one list. Let's assume it's list 1. Okay. Let me have a variable L1 which holds the address of the first node of the first list, and let's say I have L2 as the other variable which holds the address of the second list, right? So what assumption we will do is that we will start from list 1, L1, right? So I will say L1 will be the final merge list, but at every time I pick elements from L2 added to L1 at appropriate positions, right? So L1 will be the path taken by the merged list. L1 will take the path of the final merge list is what we will assume. Okay. Now, why always L1? That's again an assumption, right? So, it so happens here in our example, the value of L1 is less than L2, right? So, it should always be like that. But let's say it's not the same. Let's say if L1 has a value 20 and L2 has a value 10, what should I do? I will have to swap. For my assumption that L1 will be a merged list, I will have to swap L1 and L2 heads, and after that I can still continue that L1 will be the head of the final merged list, right? So this two variables L1 and L2 will jump one at a time, move from node to node, and will help us uh, get the final merged list, right? So that's assumption 1. um, the second assumption is what we will understand as we start this process. Okay, so let's get started. Let's have a variable head which marks the starting address of the merge list. So I said L1, right? So the coloring notation that we followed here is blue one marks a node which is added, confirmed to the merge list, and the pink ones or the red ones that you see here are the ones which are to be decided, where should they are compared. So at every point of time, L1's next is compared with, this is something uh, L2. Okay, so this is the second assumption. So I would say L1 always points to the newly added node to the merge list. It's blue, and you need to compare L1's next with L2, right? So there are two scenarios when you compare, right? So L1's next is either greater than L2 or it is lesser, right? So let's assume L1's next is less than L2, right? It doesn't happen here, but let's say L1's next is 20 and it is less than 30. Okay, the value in the L2. So what do? It just has to, L1 has to just move one step ahead, right? So that would happen, but it's not the case here, right? So here I have, one second. So when I now compare L1's next, L1's next with L2, I have 4 compared with 3, right? So I see L2 has a lesser value, right? So in which case I understand that this link should go, I should have 2.23, which is the next smaller value, right? But if I take out this link, I would have lost the address of 4. So what I would do is I will have a variable temp hold the address of this 4. I will, 3 is now a confirmed node, right? So I will have L1 move here and L2 come to 4. Yeah. Um, let's look at that task happen here, right? So as you can see, L1 has moved. So this is, as I said, L1 should always point to the newly added node to the merge list. So I understand 3 is added to the merge list, and we will have to go ahead to make it blue, right? So if you can see here, I've made it blue, and L2 is on the other side. So that was the address held by temp. So my temporary variable helped me not lose the address of that 4. So it's become L2 now. So if you could see, 2 and 3 are the confirmed nodes of the merge list. 4 and 5 are compared, right? So it's the same comparison where you compare L1's next with L2, right? So is L1's next greater than N2? Yes, I see L1's next is greater than L2, in which case I need one more temporary variable, right? So I will have this link go, I will have temp, hold the address of this, I will have 3, remember the address of 4, and now 4 should become blue, right? So let's see that 4 would become blue, and blue recently node which has become blue should be L1, right? So that will become L1, and my temp which held the address of 5 will become L2, right? So this process would continue till some point. Yeah, so let's see of what is that final point. So there are two conditions. So if you could see here, L1's next is becoming null, right? So there is nothing. So what you understand here is, I cannot compare. Till now I have been comparing L1's next with L2, right? And now it's not true for the reason that L1's next is null. So this is the point where I terminate, right? So what the only thing that you will have to do now is establish the next of L1 as L2 here, right? So that is what you do as the final thing. Yeah, so now you have your list completed with all the 10 nodes being linked, and it's time for us to jump to the execution. Okay, so this is the execution part where we have the code, the complete code to generate the list and also merge them. So I will skip the routines which talk about creating nodes, printing the list, and creating the list, right? The only concern is the merged list routine, right? So as you can see, there are two arguments being passed, list 1 and list 2, and if list 1 doesn't exist, it's obvious that the final answer is list 2, and if list 2 doesn't exist, the answer is list 1, right? So they are like trivial cases which we shall check initially, and this is the task I said where I choose the head of the merged list, right? So depending on what is the data in L1 and L2, I will choose the head. So I want the head always to start from a node whose data field is less, right? So I do that here, and that's assumption 1, which we just discussed. And this is the main while loop where I compare list 1 ka next data with, one second, yeah, list 1 ka data here with list 2 ka data, right? So if I see that they are greater, I said I will need a temporary variable, and it changes the next pointer to L2, and I have a new value to L2, right? Similarly, if it's not the case, it's just move ahead, right? The L1 would just move ahead, and as I said, when would this terminate? This would terminate as long as list 1's next doesn't become null or L2 doesn't become null, right? So that's the while condition. And finally, I will have the head being returned, right? Okay, so let's get this code running to check our logic. So there are two lists created. Okay, so we see the output here. The first list was 3, 4, 6, 7, and the second list was with three nodes 1, 8, 10. And after having our logic work, we have the final list with all the seven nodes in ascending order, right? So this gets us to the end of this discussion on of how to merge two sorted linked list into a single sorted list without creating new nodes. Thank you.